Now we're going to get to the topic of dimensional analysis. This is actually a very important skill in chemistry. What it does is it allows you to calculate different types of stuff by knowing the units that you're supposed to have. For example, you might want to know, if you're a runner, how fast you're running. Now, how do you measure the speed of a runner? What you typically do is you make that person run a certain distance away. Maybe you run like 2-3 laps. And then you measure the time it takes for the person to cover that distance. And then what you do is you use the distance and the time, you calculate the speed. The way you get speed is you divide the distance by time. Okay, so for example here, the sprinter can run 100 meters in 10 seconds. What's the speed? Simply 100 meters divided by 10 seconds. And that gives you 10 meters per second. It's a unit that is ratio of two other units. Now let's think about somebody else who wants to be an Olympic sprinter but's not there yet. She's running in this field that has a distance of 25 meters. And she knows that if she wants to be an Olympic level sprinter, she has to maintain that speed, 10 meters per second. This is where dimensional analysis becomes useful. First thing is you just look at the units. Forget about all the numbers. What units are you given? You're given the unit m, which is meter. You're given the unit m over s, or meters per second. And then what unit are you trying to solve for? They're asking for how many seconds. So you want your final unit to be seconds. So this is what you think about. Okay, I have m over s. Okay, I want to get to s in the end. Mathematically, what do I need to do? I can always do one of these four things. I can add, subtract, multiply, or divide. So notice that if I have meter and then I have second over meter, then the meters will cancel away. This meter here on the top will cancel with that meter at the bottom. But what I have is meter over second. It's not second over meter. So how do I make meter over second into second over meter? Well, second over meter is just the reciprocal of meter over second. In other words, if I actually divide meter over meter per second, I get meter times second per meter. And again, this is something you need to remember back to the time you study fractions. Meters cancel away. So then what you get in the end is the unit second. Now, what does that mean in terms of solving our problem? We need to take the number that has the unit meter, which is 25, and divide it by the number that has the unit meters per second, which is 10. So you end up getting 2.5 seconds. But you can see that I didn't know anything about how to calculate speed or time or distance. All I know is I know the units. I know the unit that I need to get to. It's an example here. I want you to try it out on your own and then ask me questions if you're not clear on how to solve this. I know it's just been a long series of videos on math stuff, but this is the last one, I promise. This one is about how we use significant figures in calculation. So earlier we learned about significant figures in a prior video about how that measures precision. We learned how to count them. Now we need to learn how to calculate things that have significant figures. And the important concept here is if I am trying to report a number that I measure to somebody else, I need to make sure that when I'm doing my calculation, I don't somehow make the number more precise or less precise than what my instrument gives me. If my instrument gives me 3 significant figures, and then I punch these numbers into the calculator, and the calculator gives me 10 digits in the end, I cannot report all 10 digits. I have to go with 3 digits. And you say, well, how is it possible that the calculator can give you 10 digits when you only give it 3 digits as an input? Well, this happens all the time. If you don't believe me, try it in your own calculator. Just try to multiply the number 3.12 times 1.79. The calculator I use happened to give me this number right here, okay? And there's a bunch of zeros that come afterwards. So then you can see that this still all of a sudden now have 5 different significant figures, even though my original numbers, each one of them only has 3. If I report 5, I'm telling the people that I'm reporting this number to that my instrument is able to measure to the level of 5 significant figures in precision, when it actually only is able to measure up to 3. We don't want to report something that is not true, right? How do we keep track of significant figures. We really should just report 3. So then that means we need to cut our reported number just to that third digit right there. And we would write the number 5.5, and then we would have to round. Rounding depends on the next digit. I want to stop here on this 8, but I need to look at the next number, which is the 4. And then there's this rule in math for rounding, which is that if that next digit is 0 to 4, you keep that same final digit. And since this is 4, you keep the 8. If the number to the right is 5 to 9, then you increase the final digit. A couple of examples here for you to think through if you're having difficulty with rounding. Now, these two are the actual rules for significant figures. The multiplication division rules is that we want to keep track and give our answer to the same number of significant figures as the measurement with the fewest significant figures. So here's an example. Let's say I'm multiplying two different numbers, 2.0 times 4.11. What I get is 8.22. The first number has 2 sig figs. The 4.11 has 3 sig figs. So the final answer must have 2 sig figs, which means I need to round it to this second position right here, okay? So the final answer would just be 8.2. Addition and subtraction, a little bit more difficult. In this case, what you're looking for is the fewest number of digits after the decimal point. Shorten that as DADP. And what we're trying to do is write the answer with matching the measurement with the fewest DADP. If you have 3.45 plus 5.1, you get 8.55, okay? This one right here, how many DADP do you have? 3.45, so there's 2. And then what about this one right here? There is 1 DADP. Well, the fewest DADP is 1, so my final answer should also have 1 DADP. Final answer should be 8.6, right? Why 6? Because it's 8.5. You want to round it to this first position, but the next digit is 5. When you have multi-step calculations, you don't round them, you just need to keep track. So the rounding only happens at the last step. Okay, so anytime you're dealing with conversion factors, you can just not worry about their effect on significant figures. Okay, all right. All right, let's work on that dimensional analysis problem that we just saw in the end of that lecture. The question says a Toyota Prius hybrid uses 59.7 liter of gasoline to drive from San Francisco to Seattle, which has a distance of 1,312 kilometers. You're asked to use the following conversion factors. 1 mile equals to 1.609 kilometer, and 1 liter equals 2.2642 gallon to calculate a couple of different quantities. One is the average fuel economy in miles per gallon, and then the other one is how much it costs you for this trip if gas costs $3.9 per gallon. Let's take a look at the first problem. I don't really have any formula or anything like that to solve this, but what I can do is just look at the units and then try to figure out how to use the units to get to the unit I want. So the first step in dimensional analysis is to figure out what units you're given and what unit you're looking for. The unit you're looking for here is miles per gallon, and that's why I say 1 miles per gallon here. What units are you given? And so you have to scan through that problem and look for units. The first unit I see, 59.7 liters, so I know that there's a unit of liter. There is 1312 kilometer, that's another unit, kilometer. Then there's these conversion factors here. So these are units, but they're given in the form of conversion factors. So what are conversion factors? They're just things that relate to different units. The same distance, for example, but then in 2 different units. So for example, 1 foot is equal to 12 inches. So when we have conversion factor, we write them as a ratio. So you have the top and you have the bottom. Call them numerator and denominator. And then the other conversion factor is the liter to gallon conversion factor. That's number 4. So I've marked those 4 things in blue. They are the units that were given. So the question becomes, how do we use these 4 things, kilometer, liter, miles per kilometer, and liter over gallon, to somehow arrange them so that in the end what we have is miles over gallon? First thing we need to think about is, of those 4 things that I listed there, which one of them has miles? I want to make sure that mile is on the numerator. The only thing that has a mile is number 3. It's miles over kilometer. So that's the first thing I would write in my conversion path. In my dimensional analysis, I would start with that unit. So I write miles over a kilometer right here. One thing we notice here is that the unit we have has miles and has kilometer in it. But we know we don't want kilometer. In the final unit, we don't have kilometer. So we have to cancel out kilometer unit. I'm trying to find a unit that will get rid of my kilometer? Well, it turns out conveniently, I have a unit kilometer right here that's just given on its own. So I'm going to just multiply this miles over kilometer with the kilometer unit, and that would allow me to cancel these. So if I stop right there, all I have in the end is a unit of miles. But I know what I'm looking for is miles over a gallon. So now I have to go to the look at the second unit and try to see if I can find something with gallon in it. I already used these two, so I'm going to cross them out. The only other two left are number 2 and number 4. Of the two of those, only number 4 has gallon in it. So I'm going to take that and put it right here, liters over gallon. I write them exactly the same way in units of liters over gallon because what I want is my gallons to be in the denominators. Now I'm going to have liters in my final unit. And again, my final unit just has miles and gallons. So I somehow need to figure out how to use this last unit, this liter. And the only way that I could make sure that the liter doesn't appear at the very end is to write that as 1 over liter. So I need to put that liter quantity at the bottom. That will allow me to cancel these two and make the liter disappear. This is probably the most confusing part of this step because students might think that, hey, how did you just put that liter at the bottom? Isn't the liter a numerator quantity? Here's what I'm going to tell you. It doesn't matter. You can put that liter on the numerator. You can put it in the denominator as long as you put that number that's next to the liter right next to the unit, okay? What you're doing here mathematically, you're just dividing, but I'm writing it as multiplication of the reciprocal, okay? I'm just going to add in the numbers that go along with the unit. So in the first one, I'm doing the miles over kilometer, so I'm just going to put in those numbers, the 1 over 1.609. In the second one, I'm putting the kilometer, so I get up to 1312, so that's why I write that there. The third one, I have liters over gallon, and that would be the 1 over 0.2642. The last one, I have just liter, and the number that goes along with it is 59.7. When I carry out this calculation in my calculator, I ended up getting this number right here, 51.69763, and this is in miles per gallon. This is not the end of this problem. And I know you're wondering, we've done so much work now, and this is still not over yet. This is an answer that shows up in your calculator. But don't forget, we have to worry about precision, significant figures in our answer. So the last step here is we have to write the final answer that has the correct number of significant figures. What do you have to think about when you're worrying about sig fig? First off, all conversion factors can be ignored. So remember, we have two different conversion factors here, this one and this one. We don't need to worry about this in terms of sig fig, okay? I'm not saying don't worry about them in calculation. I'm saying don't worry about the sig figs of these things because they don't affect the calculations of sig fig, okay? So the only two numbers you need to worry about are these two numbers right here, this one and this one. So if we count the number of sig figs for those two numbers, the 1312 has 4 significant figures, right? 59.7 has 3 sig figs. Since all we're doing is multiplying, our final answer should also have 3 significant figures. So therefore, what I would need to do is take that calculated answer and round it to 3 sig fig, which end up giving me 51.7 miles per gallon, okay? Now let's take a look at the second question. Here it says gasoline costs $3.90 per gallon. What's the cost for the entire trip? So you're basically asking for dollars, right? So we go through the same exact steps. First, we look at the unit that we won. We won dollar in the end. What units are we given? We're given the cost per gallon. So that's dollar per gallon. We're given the volume we end up using, which is 59.7 liter. We're also given this conversion factor, liter over gallon. Now, one of the things that you might say is like, well, don't we have other things too? We have the kilometer to mile and we have the kilometer, but those things don't really pertain here because adding them doesn't really help you solve anything. You just need these 3 given units here. Then the question becomes, how do I arrange these 3 units to give me the unit that I want, which is dollar? So I want dollar. Well, just like before, I'm going to look for something that has dollar in it. That's the first one right there. And I'm going to write it as dollar per gallon. Then now I need to cancel my gallon because I don't want gallon in the end. And then, so once I use that, there's only 2 other left. And the only one that has gallon in it is this one right here. But I have to flip this. I have to write it as gallons over liter. Why? Because I want to cancel this gallon with that gallon. So the gallon has to be on the top for this one and then the liter at the bottom. But if I do that, now I have liter and I need to cancel out the liter. Well, the only thing I have left at the end is the liter. So all I need to do is multiply it by that unit and I should be done and I get dollar at the very end. Now, the next step is to perform the actual calculation and that gives me the final answer. I'll leave it up to you to actually calculate that answer and more importantly, figure out the correct number of significant figures for the final answer.